Okay, so today we're looking at further antiderivatives. So our learning intention is to gain the knowledge in calculating the antiderivative of a function, especially of exponential, logarithmic and trigonometric functions. So you'll be successful if you can integrate exponential functions, log functions, and trig functions. Okay, so what I've done is I've kept the rule that you will see on your formula sheet on this side, and I'm going to do some examples in here. Okay, so for example, just bear with me. Alright, so if we have y dash equals e to the 2x to the power of 2x, we're wanting to find the primitive, we want to find the original function. So that will fall into this type of formula. Okay, so what I want to do is I want to compensate for this derivative of 2. So I'm going to put a half e to the 2x plus c for the constant. So that says if I was to differentiate this, I shall get that. So bring the power of 2, 2 lots of halves is 1, gives me e to the 2x. Alright, so here I have negative 2x, so what I really want to do is divide that by the constant. And that's going to give me negative 3 lots of e to the power of negative 2x plus c. Alright. Something like this, y dash equals 2 to the power of x, falls into this type of derivative. Okay, so let the function be x. The derivative of that is 1. So this is going to be the function over log of a plus c. Okay, where a of f of x, that's this part here, that goes on the top. The derivative, so the derivative of this would be 1. So we stay there. Okay. Something like this, y dash equals 5 to the 2x. Okay, so in this situation, if we let I'm going to do the substitution rule. So let u equal 2 to the x, then du dx equals 2. Okay. So and then obviously, so dx would be du on 2. So this can be written as 5 to the power of 2x, but if I'm using the substitution, be 5 to the power of u, sorry, that dx, u, which is du over 2. Okay, so that's going to be a half of 5u du, where I can just use this rule, where it's going to be 1 over log 5. So y would be 5 to the power of 2x over 2 log 5 plus c. Okay. What about logarithmic functions? So there's the rule. So f dash of x over f of x dx is log f of x plus c. Okay. So if I've got this y dash equals 2 of x, well, that's like 2 lots of 1 over x. So I need to compensate for that. So that's going to be 2 log of x plus c. Y dash equals 1 over 3 minus 2x. If I let f of x be 3 minus 2x, then f dash of x equals negative 2. Right? So what I really need is something like negative 2 on 3 minus 2x. Yeah. To give me something like log of 3 minus 2x plus c. But that's not what we have. So I need to make a compensation for this negative 2. So that's going to cancel that. Basically, I'm going to have a half to compensate for that 2. So y equals negative a half log 3 minus 2x plus c. Okay. Now this one I made an error because it should be x over x squared minus 4. Okay, so if f of x is the denominator, f dash of x is 2x, which is very similar to here, but I need an extra 2. So if I was to get 2x over x squared minus 4, right, that would give me log of x squared minus 4 plus c. But I don't have 2x, I only have x, so I've got to have to compensate for that and take out a half. Okay, so this would be a half of log x squared minus 4 plus c. Okay, same thing for this one. Of f of x equals x squared minus 2x plus 4. F dash of x equals 2x minus 2, which is 2 lots of x minus 1. Yeah, so if I had 2x minus 1 over x squared minus 2x plus 4, right, that would give me the natural log of x squared minus 2x plus 4 plus c. But I need to compensate for that too because it's not the same as here, so I'm going to be another half as well. So this is going to be a half of log x squared minus 2x plus 4 plus c. Okay. Here is our trigonometric functions. So we've got sine, cos, and sec. Okay. Okay, my solutions. Okay. So for this one, y dash equals sine 2x. Well, that's just going to be the inverse, the opposite, or the anti-differentiation of sine is negative cos. So, yep. And I've got 2x, so I need to compensate for that 2x, so it's a half. Okay. You can check it because to differentiate that, 2 times negative a half is negative cos, but differentiate negative cos becomes so negative cos, negative sine, so 2 negatives become positive sine. Okay. Here we've got cos x squared, so we're going to compensate for this half. Sorry, x over 2, this half. The differentiation of cos, differentiate is sine. So we get 2 sine x squared, x over 2 plus c. So this one here, what I'm going to do is it's the same as writing it as sec squared is a half on pi minus 2x. Now if I let's say u be pi minus 2x, I get u on 3. Okay. So if I was to integrate that, I would get 3 tan on u on 3. Plus c. Well, u is just pi minus 2x on 3 plus c. Okay. For this one, I'm going to use the u substitution rule. So I'm going to so we can write this as sec squared x over 1 plus tan x dx. So let u equal 1 plus tan x, and then du over dx equals sec squared x. So dx is du over sec squared x. Right, so if I was to place in that substitution, I get over u. Now dx is du over sec squared. These cancel out, leaving me the integral of 1 over u du. And we know that that's going to be log of u plus c. So the primitive is log of 1 plus tan x plus c. Okay, and that's everything. All right, thank you very much.